Essay 38, Electron and Proton Resonance Induced by B3. I started to think about optically induced ESR and NMR in the late 80s at IBM Kingston, New York, where I was a visiting professor in the Clementi environment. After finishing my year there, I decided to stay in New York State and become a private scholar, having the intention to forget all about the people who gave me so much trouble in Wales. No longer having access to the supercomputers in Kingston, I worked on theory at nearby Port Ewan near the Hudson River. Many papers in leading journals were produced as a private scholar. After a few months working in Royal Holloway College of the University of London, where I was given an honorary but unpaid fellowship, I returned to work as a private scholar in the Hudson Valley near Kingston. Clementi offered me a position as the Mortec writer, and I was allowed to use supercomputers again. During that time, I came across a paper by Georges Vanier of the University of Zurich on the inverse Faraday effect. That was the first time I came across the Pierre-Carre-Kielich conjugate product and its ability to use electromagnetic radiation to produce magnetism. Shortly thereafter, I was offered a visiting position at the new Cornell Theory Center, but this was unpaid, so I spent a lot of time working as a private scholar from home. I allowed Cornell to use my work as publications of the Cornell Theory Center. In one of its quarterly reports to NSF, Cornell Theory Center devoted a whole section to the numerous papers I produced on its behalf in leading journals. I was not told of the existence of this report. It was found by my first wife, who was always a great help. So there is always a certain amount of devious behavior in academia. In the Omnia Opera of www.AIAS.us, all the papers are carefully archived, so act as source documents, leaving no doubt as to the impact of my work. This work gradually evolved into optical NMR, which was taken up by the Warren Group at the Chemistry Department of Princeton University in my early months at Cornell Theory Center. Warren was a referee of one of my papers and invited me to Princeton to advise on experimentation. At about the same time, I was offered a year in the University of Zurich as guest of the university. This was a paid position, a rare occurrence. By the time I took up the Zurich position in the autumn of 1990, the brilliant animation of the inverse Faraday effect by Chris Petley was ready. The animation is now on www.AIAS.us and shows that the circularly polarized laser spins molecules. This is not clear at all in the complicated mathematics of the inverse Faraday effect, and the spinning motion is what gives rise to magnetism. Unknown to me, the idea of a B3 field, which I developed as a private scholar in about November 1991 back at Cornell from Zurich, was being taken up by Taishi Kurata in Kobe, Japan, who began the development of the various Kurata B3 technologies. In the US and Britain, however, the system was totally unable to provide stability or any support. Cornell, for example, was quite happy to use my work, but forgot to pay me. This is why the Kurata B3 technologies were never developed in the West, a major historical failing. As usual, all they had to do was find a salary as a permanent research associate. As it was, I was forced to move to an obscure place called University of North Carolina, Charlotte, a name that will live in infamy in the annals of physics. As usual, I outproduced the rest of the department, combined with private scholarship, but was subjected to the notorious conspiracy known to the world as UNCC. See source documents on www.AIAS.us. In late 1994, I inferred the technique known as radiatively induced fermion resonance, RFR, in which microwave or radio frequencies are used to induce magnetization through the paramagnetic inverse Faraday effect, the interaction of the spin angular momentum of a fermion with a B3 field. It became clear that this technique has great advantages over ordinary ESR or NMR, which works with permanent magnets, as is well known. RFR works without magnets at much higher resolution and also produces an original spectrum or chemical shift pattern. The theory of RFR has been developed in many articles and reviews on the Omnia Opera of www.aias.us and is straightforward, easy to understand. The experiment for one electron is also easy to set up, consisting of the interaction of a microwave frequency beam and an electron beam. With the advent of a full-scale industrial plant based on Kurata B3 technology, it is hoped that RFR will at last come to fruition. However, that will have to be done by small companies working outside an academic system that sometimes seems to be incapable of any really useful progress. This is also Kurata's own point of view, expressed in his acceptance of an AIAS fellowship in about 2001. The letter from Kurata has been syndicated and is available on the net.